There are no minions. Hey, Ben.
Hey, Matt.
I left that a bit long, didn't I, this time? That was a bit later in the intro. I was like, oh, because I was chatting to you before pre-show and then, I got distracted.
How long could you go not saying that before people would just be like, is this thing broken?
Are we on the right
Is
podcast?
This the right podcast? I don't even know.
I have a funny story about that. Maybe we've already said it, but one of my pals, one of my C++ pals, his name is Ben Dean, right? And he's also British, and and so like he was listening to the first episode of the podcast, and he just nearly fell off his chair because the first thing I do is go, "Hi, Ben," and he's like, "How? What?" I mean, I'm sure that other people called Ben exist. I appreciate that, but like it was just him telling the story that made me laugh.
So it's like, did I forget to leave a phone call or a Google Meet somewhere? And
now someone is just talking to me.
Like,
yeah. Hey.
Yeah.
Hey,
hi. You left your phone on.
You bum dialed me. Yeah.
Yeah. Exactly. Yeah.
We've all been there shouting as loud as we can, trying to get someone's attention. But yeah, not that. But anyway, I wonder how long we could get away with. But it's what we do. It's what we say. Another thing. I met somebody who is a listener. Or our listener, singular.
The listener. You met the listener.
And it occurred to me that's about the fourth person now who's told me that they are our listener.
So we have 4 listeners.
We might have to accept that we have more than one now. It's so funny, given how the internet is all about tracking, and every YouTube video tells you how many people have watched it and all that kind of good stuff. It's really hard to know how many listener there really are out there.
Oh yeah, yes.
It seems broken
because of one of the classic problems of computer science, cache invalidation.
Yeah. Yeah. Everyone wants to cache your. I mean, I suppose that's the thing. Like videos, nobody would want to cache gigabytes of videos. But you're like, hey, a couple of meg of MP3 file, sure. Spotify, we'll take a copy of that and we'll hand it out to everyone when they press play.
Yeah.
And then we get you to try and sign up for our Spotify podcast publisher account that then lets you see how many plays you've had on Spotify. I'm like, that's great, right. But you can also listen to it on Apple and Google and YouTube and off of our website. And you can pay. There are these places that will charge you decent amounts of money to tell you how many people listen to your podcast. But I'm just like, somebody should write a web scraper that goes to all of these places and gets them all in one place, right? And by somebody, I mean probably an LLM that I could just tell it to do that thing. Anyway, that's not what we're here to talk about today.
No, we're not. What are we talking about today?
We're talking about the last 3 days of my life, which have been supposedly preparing for conference presentations, which I have in September. I've got three conference presentations coming up, which is great. And you want, while you're sort of writing slides and throwing out ideas, you're kind of like, well, I want a background window that I can kind of just tap into occasionally. And there's tons of stuff in Compiler Explorer, which is just like, hey, run this thing, wait for it to finish, have a look at the output, see if it makes sense, push it to production if it does, updating libraries, that kind of good stuff.
Mm-hmm.
And so we've hit August now, which I believe will be actually when this podcast comes out, in a rare departure from the norm.
That's right.
But we've hit August, and I've long since had a calendar reminder to say, hey, we should really upgrade to Ubuntu 24 for all of the production nodes for Compiler Explorer. And, we tend to drag our feet a little bit because we've been bitten before. This is where we should see a big,
oh boy,
a big foreshadowing thing you should pop up here. And in fact, 10 years ago, we were bitten by an issue. I was doing some research of trying to work out what happened, and I found my own blog post from 10 years ago.
Oh wow, yeah.
That kind of thing where you're like, oh, who had this problem? Oh, I had this problem.
Former me.
So anyway, how hard can it be to upgrade the operating system? We have everything scripted through the wazoo. We use Packer to build our images, all of our images, apps install all the things they need, and then they shut themselves down.
Mm-hmm.
Great. And then, we make a machine image out of that. And that's what starts up and is a compiler explorer node. Pretty straightforward. And we do this fairly often because if you don't, then it rots, as you know, when you're relying on a ton of stuff that's, install this from this random website. So anyway, that wasn't a problem. So in theory, it was just change a 22 to a 24 and then rerun the Packer. And it failed the first time.
Yeah.
For an easy to diagnose reason. Luckily, I'd already hit this before because I started a 24 upgrade for a different part of the system and hit it. I was like, oh, I must remember this. And of course, completely failed to remember to do it this time around. Which was to do with the way AppArmor has been updated and some of the jailing things that we do. Obviously we run things in secure environments, and AppArmor has opinions about which things can run. And certainly our own jailing code needs to be configured so that it can do the things that are usually dodgy, like, hey, I want to make a whole new namespace. I want to make all of these sort of isolated environments. It's like that shouldn't just be allowed to happen randomly. So AppArmor comes in and tells you, no, you can't do that. And then Compiler Explorer doesn't work. So we fixed that. Cool. Deployed. Anecdotally, it took a while to start up. And I was like, watched pot, never boils kind of thing. But to sort of make this slightly less of a Shaggy Dog story than it already is going to be, it turns out that our boot up time went from not a great couple of minutes to 4 or 5 minutes. It was timing things out. And even more interestingly, while the node was booting up, it was unresponsive. Like SSH would time out, and I'm like, what is going on here? What on earth could it be doing at startup that could bring it to its knees like that? So what it ended up being is that at startup, we mount around 2,000 SquashFS images. And I don't know if we've talked about this before on the podcast, but Compiler Explorer has a very unusual... Yeah, okay, so let's do a bit of an interlude. This is definitely a therapy session, by the way. Thank you, Ben, for being my therapist. And thank you, listener, for being
you
therapist.
You spent 3 days of your life on this. You deserve to be able to vent about it.
I'm going to feel better. Right. It's catharsis, yes.
Yeah.
So Compiler Explorer has many compilers. They are immutable because once I've installed GCC 12.1, I never need to do anything with it again with a massive footnote. There's sometimes we break and we have to redo them, whatever. But they also need to be shared amongst up to about 40 different machines. And that constitutes about 2.5, 3 terabytes of binary files. There's just not really a good solution for I'm sharing that amount of data with the kind of access patterns that are, well, it's a compiler, it's an executable. Right. I'm going to run it from NFS or wherever you're storing it.
Yeah.
So, the first thing, when we first started out with Compiler Explorer, every node, all the compilers were built into that AMI image. So that the image that I said I was building from 22 to 24 would actually contain the compilers. They were actually apt installed at one stage, and that was okay, but it does not scale.
Right.
Because, effectively every build gets slightly slower than the previous build as more and more and more images, more compiler images get sort of unpacked onto it. And that once it took more than 24 hours to complete the AMI image, I knew that we were in trouble, and I thought we have to come up with a different solution. So we used NFS, and NFS was great for a while. We hit some funny performance issues with NFS just out of the gate, but ultimately we got that kind of settled down. And then things like Boost, which is a C++ header-only library, it makes a lot of use of the fact that you can include a file from itself. You can self-reference the file, and so it has a bunch of preprocessor trickery that includes the file multiple times and hash defines something to be, n+1. So it can include the same file 50 times to get expanding out of certain things that you can't do in the template system. Those kinds of tricks, right? either way, what that is tiny text files, including tiny other text files, which is like the worst case scenario for NFS, right? You've got this massive, even if you cache the file contents, NFS will always go and fetch or pretty quickly will go and fetch the metadata to see if the thing has changed on the remote side before it will serve up the cached content it has locally. And at that point, you might as well have just read the darn file because it's 80 bytes long, right? So latency, massive problem. And so Boost was timing out. And so our first solution to this was we would rsync a few libraries to the local disk when we started up so that they were local, and then sort of substitute the path. Great, lovely, but not scalable because we have thousands of libraries, and then the boot up time was getting longer and longer as well. So take two was for every compiler or library that is like a final build, like a 12.1, a released compiler, we install it on NFS, but then we also build a SquashFS image of that compiler.
Okay.
That SquashFS image is also on NFS.
Okay.
Which, so far, you're thinking like this is just manifestly worse, which, maybe it is. And then at startup, we mount the SquashFS image over top of the NFS location where it is also stored. So it looks like we have one unified opt compiler explorer, all the compilers in the world, but some of those directories in there have actually been mounted over top and are actually being served from a SquashFS image that's on NFS as well. Right.
And the intention here is to sort of solve the tiny file problem. And instead of shipping across an 80 byte file, you're shipping across a SquashFS for a particular compiler, and all of the bits come along with it in one swell foop.
In one swell foop. It's actually better than that, because the way SquashFS works is, yes, it does do packing of smaller files into an area. It also compresses them. And as far as the kernel is concerned, SquashFS is like a block device file system, like a hard disk. And so the kernel is caching and loading things as like 4K pages, 8K, whatever size it's reading and writing. SquashFS doesn't know that the underlying image is actually on a mutable network file system. And so it caches them forever. It's like, yeah, fine, I'll keep this in my page cache, right? I read page 7 of this file system to hand to SquashFS that then unpacks it, and then the files are also cached, right? But the raw block level accesses are cached essentially forever. We've laundered the fact that behind the scenes, it's an NFS drive. And so we get much better caching, much better performance of like reading the metadata for things, because like you read the directory contents and it gives you like a 4K block that probably has all of the directories for everything that's inside that SquashFS image. And then the tiny files are all packed together as well. So like we're winning on every level. And it was a huge improvement in the compile time. But it's not free to mount the image in the first place. And obviously it takes up a little bit of memory on the machine to have like 4,000 or 3,000 mounts, right? So each mount, takes up a certain amount of kernel space, and part of the acceleration is that pre-caching, effectively, of that sort of top level of the directory of every compiler and library. So over the years, we went from tens to hundreds to thousands of compilers, and our boot up time became dominated by, it takes 50 milliseconds to mount each SquashFS image.
Yeah.
Times 2,000. Suddenly that's an appreciable amount of time.
Yeah.
And so then you're like, what if we do this in the background while we're starting up? And then that didn't work out. Now I know why. So anyway, that was the situation that we're in. That's why we mount thousands of files at startup. And we have any number of ways of thinking about consolidating the number of SquashFS images we have so that we can combine all the GCCs together in one image or whatever. But there are a number of other issues with that, which is a whole other podcast episode. And every time I describe this problem to people, by the way, everyone's like, yeah, I don't know I can't think of a solution to this problem. Like this is the general problem of like, I need to ship immutable binaries with low latency to many places. And I can't, and I need to take advantage of the immutability as much as possible. And and then the management of that, right? I've got thousands of these things, right? Anyway, so the problem turned out to be when you mount an image on a modern Ubuntu, systemd comes along and says, "Oh, you've added a mount. I need to make an ad hoc unit," which is kind of what it's kind of dependency tracking node in its graph. I don't know much about systemd. I've learned a lot more about it in the last few days, but what it effectively does is it creates a node in some dependency graph so that when you shut the system down, it knows to unmount it and it knows who depends on it and things like that, right?
Okay,
Sort of that stuff. Because
right.
you can also phrase the entirety of etc. fstab or certain services to say, hey, this service needs this thing. And this thing is a network mount, and that network mount needs networking, and networking needs to be. So systemd can follow this graph and say, well, if you're turning on this service, I'll make sure all the mounts it needs are in place. And when you turn it off, I can unmount them as well. So it's, it makes a ton of sense.
But I discovered actually, side note, the other day that systemd also does that for shared memory directories.
Interesting.
Which bit me in a very painful way. Because of a technology that you're familiar with that uses shared memory for storing data.
I'm aware of that.
And it suddenly disappeared when we turned this service off. And we're like, what just happened?
Oh my gosh.
Yeah.
Yeah. systemd has its fingers in a lot of pies.
Mm-hmm.
So when you mount an ad hoc thing, be it apparently shared memory or a squashfs image, which itself is mounted through loopback, which is another sort of mount, which is all that kind of stuff. systemd tracks it, and I don't know what systemd is doing to take so long, because this is the rub. Systemd essentially takes 100% CPU twice over. So on our 2-core machine that we run these things on, I can run top. When I actually got it, I said to you the machine was unresponsive, right? Because it's all in kernel land. Locks are being taken out left, right, and center. We're trying to mount these things in parallel at sensible levels because we want to try and mount them and deal with the latency. If it takes 50 milliseconds and most of that is network latency, I should be able to fire off 2 or 3 mounts at once and get the squashfs, read the root directory and then have the mounts, whatever. Even if the kernel is like sequencing them, you'd think I'd like to have some mounts on the go at once, but no, every time that comes in, systemd does a ton of work. And so PID1, which is, init,
right,
but is called systemd on these systems, takes 100% CPU, and a second process called systemd, which is the one that is per user, I think, takes 100% CPU while this is going on. And that is not the case on Ubuntu 22. It does take some CPUs, like I measured 30 and 40% of those, which again is like, what on earth are you doing? But I'm sure it's got this massive dependency graph that it's running through. So yeah, the short answer is Ubuntu 2024, either the systemd has changed or some aspect of the configuration, and every time you mount something, it takes a little bit of time, which is probably not a big deal, but unless you're doing 3,000 of them back to back, or trying to do 4 of them at a time, and then it jams the system up completely. And the knock-on effects for this, when I rolled out the 24, was our machines took ages to boot, but they did eventually come in just under the threshold of them getting whacked by machine did not come
the
responsive,
timeout, essentially.
Exactly. But of course they've been chewing 200% CPU for like those 3 minutes while they were booting up. And the way that we do our auto scaling for our cluster is we take the average CPU of which is a terrible metric, but it's also the simplest one to do in AWS. Now we've got one of our committers is working hard on getting a much better way of scaling up and scaling down and using metrics that make sense. But the only sensible one that you can go to that just has a drop-down entry in AWS is add or remove nodes from the cluster to keep the average CPU at blah. And so we've got that set to like 30%, 25% right now. So which is, again, not ideal, but it does mean that now suddenly you get into this runaway situation where a little bit of load comes in, you fire up a new node, and for the 3 minutes, it's taking 100% CPU, which pulls the average up even further. And before you know it, you have 40 nodes that are booted up. And then once it hits that maximum of 40, obviously the CPU thing
Yeah.
plunges down, and so it quickly stops dropping them all. But then, so we rolled back to Ubuntu 22, and I spent the last 2 days or day and a half trying to turn off systemd, try to disable this part of systemd, try to add every mount option known to mankind to the end of the SquashFS thing to say, for the love of God and all that's holy, don't track this. I don't care. Well, I'm going to mount it and then I'm going to throw it away. And neither me, my internet searches, or any of the LLMs that I ask could come up with a way. It just doesn't seem like there's a way to do it. In fact, by the end of one session, Claude was saying, you really need to file this as a bug. And I'm like, I'm probably doing it wrong. I still think I'm doing it wrong, right? And, for the longest time, having 3,000 things mounted is not really an ideal situation. And so that was fun. Yeah, you're pulling the face of,
I'm just thinking, is there really no way to tell systemd just not to track these things?
I couldn't find it. You can do all these sort of repressions and things, and it still didn't, it was still being thrown through it, and it's monitoring some mount thing. The best I could do was kill minus stop on the second systemd process, like the user level systemd process, which essentially is like a break pointing it.
Yeah.
Then mount them all, and then kill minus cont the process. And that got rid of one of the 100%ers, but that process is sort of lazily on demand created. So until you start doing work that needs it, it's not there. And so my scripts were dying because they were trying to send it the stop. And it was like, well, that PID doesn't exist yet. And then I'd log onto the machine and finally get through. Yeah, computers, man.
I mean, how do they even work?
I mean, how even? And so,
wow.
And so what I would ideally like is to not... Well, first of all, I would like to have a much cleverer way of managing a large nest of SquashFS images. And in fact, this whole approach to mounting SquashFS images through NFS and whatever was something that I was doing around the same time that the company-wide solution at Aquatic was being developed. So there is no surprise that the thing I've just been describing to you is familiar to you, at least in part, because some of the, for our audience, and I don't believe it's revealing any IP, we will have to do some very creative cutting if it is, but Aquatic has a solution for storing environments by effectively putting them in SquashFS images. And, that's not new either. That's what snap images are. That's what flat packs are, or various types of things. They just mount them. So like this is one of the ways that one solves hey, I just want an immutable bundle of things.
Yeah.
And then one of the people who worked on that from Aquatic, who is also a compiler explorer committer, has come up with some solutions that are a bit more clever about like having a list of symlinks that point from the file system to a well-known path, and that well-known path then has AutoFS that auto-mounts the thing on demand, and so you still present this this apparent file system that looks like it's got every compiler known to mankind, but only when you actually cd into the directory or try and run it does the symlink get resolved, and now that SquashFS image gets mounted and it appears in that position, and then you can carry on with your life. And that's great. And obviously, if we designed it from the beginning for that, we'd be able to just retrofit. It would have been fine. But retrofitting it into our current setup is really, really, really difficult. And then you still have these problems. So there's that gives you on-demand mounting, which is one thing you can do. And you could try and configure AutoFS to do this, but there are a number of reasons why it's difficult, which are much too complicated to go into now. So it doesn't just work out of the gate, although it sounds like it ought to. But we don't really want 3,000 SquashFS images. That's a pain. I do want to have like, here are all the GCCs. And what you could do is mount sub parts of those images into this unified tree, which means that like, hey, I've got all the GCCs, but now GCC 15 has just come out. I don't want to have to rebuild that image because that's, 500 gigabytes of GCC, and SquashFS is immutable. You can't add things after the fact. You have to unpack it and then repack it again.
Right.
So if your solution for, well, I'm adding one more GCC is unpack all the GCCs and then repack all the GCCs with the new one, then you're kind of back to that original AMI problem we had, that it's going to get incrementally worse every time you add a new thing. So what you really want to be able to do, again, is like have this, well, all of the GCCs for the last 10 years are in older GCCs, but they are mounted in each one individually. It's one image that has like the old ones, and then periodically you add kind of layers. This is sort of like a layer effect.
Yeah,
and then
right.
you consolidate the layers. You can have a process that goes away and says, hey, layers 3 through 9, I can now net them out and make a new layer 3, and then I rewrite the file system to be these things. So that's where we want to go ultimately with this.
Mm-hmm.
But there isn't a quick MVP for it that gets me out of my current hot potato situation right now.
So
and we've tried it
to Ubuntu 22.
We're back to Ubuntu 22. Although I had a sort of an idea. So while banging my head on my keyboard, trying to go like, how even does system D notice when I mount things or when I do stuff to the system? I was like, wait a second. What if I wrote something that looked at file system accesses? So I have, for every file that's stored in a SquashFS image somewhere, it is also out naked in NFS, because if you if SquashFS isn't around or whatever, or for those things we genuinely update quicker than the SquashFS images, it allows me to have access to the files that are just in that opt compiler explorer, right? So if I could post hoc, that is, run some trace through the whole system and say, hey, anytime I notice somebody accesses a file that is on NFS, that is inside one of the directories that I have a SquashFS image for, that's when I'm going to choose to mount it. And for the first few times, they're still going. They're still reading from NFS, but once that mount has
eventually
finished,
when it mounts,
we swap in, or flip in, or something, I don't know. Sweep in. Fly in the mounted SquashFS image over the top. And so that is what I've been doing for the last 2 hours, which is why I was slightly like, let's just talk about it. It's top of mind for me right now. And that's showing some early promise. So on this world, what we would do is we would not mount anything. And then we'd run this daemon, and all it does is sit there and watch file accesses and then sort of lazily bring in the SquashFS images. And obviously, in the worst case, a compiler explorer node will eventually mount all of the images, but likely as not, it'll never get close.
I was going to ask you about that. Is like, does that mean that as the compiler explorer nodes are running, they're just slowly accumulating these SquashFS mount points? And do you need to like clean them up on any sort of regular basis, or do you just restart the machines every once in a while? Like, how does that work?
Well, so in the current situation, we just mount them all at startup and they're up forever. So that's
okay,
end, right? So this would
be
the
only memory they're really consuming in that state is just that small amount of kernel memory that you were talking about before.
Yeah, which isn't that small. I can't remember what it was, but it was like a trivial enough, non-trivial enough that you can see that the machine's like memory has gone down, having finished mounting everything.
Yeah.
Like, oh, well, which is less than ideal. So yeah, at the moment we pay the cost for all of them, even though we have some like GCC 1.23. How often do people use that? Probably not very often. And again, we have 40 nodes. They're recycled really quickly. It's very unlikely that any one node will need all 3,000 in its lifetime. So in this new world order, the way that I was imagining it is, at least for V1, we just mount them and leave them up because it's no worse than what we have before. It might take an extra half a second, even a second, to mount the access the first time, but we're not holding up the compile in that case. It's just going through the slow NFS part. And then and also obviously the SquashFS image is extra NFS accesses that we didn't need to do otherwise, but the hope is it'll net out pretty quickly, and then by the time we either run it again, or even by the time it's finished the first reading of like the ELF and it's starting to look at the DLLs that it needs to load in, then it's going to pull the DLLs from the SquashFS image. So that is the hope. We'll see how it goes. I have already found one situation where the SquashFS image is not actually up to date with respect to the changes on the disk, which is like, this is going to throw a spanner in the works.
Yeah.
So that is an issue.
Interesting. I guess you could have the daemon that you're writing actually do that, right?
It would,
maybe.
I guess so. I think I'm just going to go kind of caveat emptor. We'll find them as we hit them, or maybe it'll be something we do as a post process that's just running and looking for things that are out of date. And
I guess Well, I guess the other thing you could do with that is, and you probably have this already, but you could farm that thing for usage statistics, right?
Yes. In fact, about a year and a half ago, we changed the privacy policy and our back end to track statistics, because we don't like to track things. That's not what we're into.
Yeah.
I don't care what you're doing with it, really, but it is
Right.
incredibly useful to say how often do we use this compiler versus that
Right.
compiler, which I think is a fair use of non-identifiable
For
information.
exactly like problems like this, where you're just like, I'm optimizing these things, I'm going to optimize them based on the usage, not on like,
Exactly. And so
random things.
so certainly we can do things like down the line, we can do things, like, hey, let's have a cluster that only does legacy compilers, right? And then that cluster just sits there, lives there forever. There's 2 machines that run all the time, and they sit there in their old timey world, and requests for GCC 1, 2, 3. They're on the front porch with their shotgun across the lap.
Chairs.
Yeah, that's right. Waiting for yeah. And then we could even have, conversely, some faster nodes that are serving the GCC, 15.1s that have just come out, and the trunk builds and things like that. But our management is not good enough. Our at the moment, having multiple clusters is painful for us, and so we have kind of 2 or maybe 3 clusters. One for the GPU things, one for the ARM compilers, and then one for everything else. And retrofitting in everything without breaking a site is so hard. This is why, when we did our talk, a conversation, and you talked a little bit about your sort of branch-based deployment, that was like, oh man, I wish we thought of that ahead of time.
Twist the knife. I mean, I think it sounds like at the scale that you guys are at right now, just spinning up one of those environments would be prohibitive in terms of cost, but maybe you could structure it in a way where it wasn't quite so bad,
So cost is not such a big deal anymore, and I say that with a massive footnote. People are surprised at how relatively cheap Compiler Explorer is to run. We're currently at around about $3,000 a month burn rate of AWS stuff, although it's just gone up, but it's gone up for good reasons. The good reasons is that I've sent a message out, a blog post. In fact, that's what we call these things, a message. I've made a blog post kind of
you made one internet and you sent it out into the webs.
I did. I sent it out into the webs. About the cost breakdown of Compiler Explorer. I did a big sort of dive into it so I could justify, we're very lucky. We have a lot of commercial sponsors. We have a lot of people who donate on Patreon and GitHub sponsors, and my dog's barking, which I can't be bothered to edit out. So we have a lot of money coming, which is fantastic. And I like to be very upfront and open about what we do with the money as much as I can within the reasonableness of the fact that it's still my private finances at some level still, right? I'm sort of hand waving and gesturing about this type of stuff. So I like people to know where the money's going. And so telling people like, this is what we spend it on and this is how much it breaks down to. It was interesting. And so it ended up on Hacker News, which was great. And one person said, have you ever considered talking to, the Grafana people or the SolarWinds or whatever, the people that we pay money to for subscriptions for like monitoring stuff. I was like, yeah, kind of, but there's something to be said for, it's not that much. It's not a huge, that's costing me, $40 a month. That's kind of noise. And I don't want to give up too much of my, I don't want to sell out. I would rather pay $40 a month than them say, hey, you have to put an ad on the top if I say thank you. And I'm like, I don't know if they would do that, but that was, we went back and forth on that, and then he was like, oh, you do know that AWS have an open source budget? And I'm like,
oh yeah,
the what now? And so I looked it up, and it was a blog post from like 2012 that made some mention of, hey, if you're an open source project, contact us, we might be able to help you. Here's a form to fill in. And I'm like, okay. Now the form looked complicated. So given how old the blog post was, I just emailed the email address that it said. I said, hey, is this thing still on? Right.
Right.
I'm the creator of Compiler Explorer. I'm interested in talking if this thing's still on. I immediately got a email bounce, and I thought, well, there you go. That tells me. I'm glad I did this rather than spending all the time to look at. So I thought nothing more of it. An hour and a half later, somebody replied going, oh, wow, yes, we use Compiler Explorer. We'd love to help. definitely fill in the form and send it to us. And I look back at the bounce, and it was like, oh, it must be one person's inbox is full of the distribution list that it ultimately ended up. So I filled it in and thought, and it asks for what is a year's amount of money that your site or your project might need. And so I was like, I guess $3,000 times 12 or $4,000. I can't remember exactly. I think it was $3,500. So 36 grand, which, is like monstrous amount of money. And I was expecting them to just say, no, seriously, how much do you need? And I thought, again, nothing more. Someone much more business oriented got back to me and said, we'll be back. We'll get back to you within. Thank you for your email. We'll be back to you within 30 days. And I thought, all right, now it's gone into bureaucracy. We'll never see it again.
Right.
And I just happened to log into my AWS account, and I saw a 36 grand credit had been applied to it. And I had to email them back and say, like, okay, before I even talk to anyone, do I have to tell people about this? Do I have to go out of my way to like thank you? What's the deal here? And the woman eventually got back to me. Oh, sorry, I meant to tell you that you'd been approved. I'm like, were you just going to let that hang? Wow. And so the short version, this is such a off topic thing, is that AWS are now funding the cost that I put forward, like the year cost as it was last year, which means immediately you're like, oh, maybe we can start, running more instances and whatever, because I have the cash for it now. So it feels it's more like I'm treating it like a subsidy. But what I'm mindful of is they may not renew it at the end of this year, in which case, I have to be able to scale everything back again. So there's a bit of thought.
Yes.
So I don't know. It's an interesting situation to be in, but it's an amazing situation in the short term. It means like I'm looking at like Redis caching, whereas before I was like, I don't really think that I can justify, another $100 a month just to have something that I might not use, or these kinds of things. So it's very exploitative. So I'm excited about that. But
that's cool.
How did we get to this? I'm forgetting. Yeah. Oh, yeah. You were saying about how expensive it might be.
Yeah. The branch-based stuff might be too expensive, but
now it might be okay. I honestly, I look at my load balancer now. So load balancers cost what, $10 a month plus the transfer? Maybe.
Yeah. It's the data that you really pay for there, right? Yeah.
It is. Yeah. And I've often wanted to have multiple load balancers, one for each. Like I used to have subdomains for like our staging environment and things like that. And then I made it so that every subdomain ends up in Godbot or comes to Compiler Explorer. So you'd have to be like, say, www.staging.godbot.org, and then you're into multi-level DNS, and that's a pain in the bum because you can't do wildcards and all that kind of stuff. But I stopped doing that because I was originally using it to route to a different load balancer. But to have one load balancer per environment was expensive. So everything now goes to the same load balancer, and it's URL matched to go off to its merry way. And that's not scaling all that well now. I've got multiple of them, and there's other things on there. And, there was a time when $10 a month for another load balancer was like meaningful. And now not to, put too far to it, that's noise. I don't know about it. So maybe I should explore branch-based development.
If you can spend $10 a month to make your life a little easier, I would suggest that you do it.
Yeah, that is the cost, I think, right now is, the trade-off between the cost of time, and I have supposedly 3 presentations to prepare for and not be doing Compiler Explorer stuff. And then I've got kind of 2.5 clear months before I have to go and work for a real job.
What?
I know.
A jobby job. That sounds terrible.
I know. It does, doesn't it? It sounds awful. So, I'm sort of very much top of mind thinking about how I'm going to go back to work, Ben. I don't know.
Yeah. Well, I think in the first week, you're going to be like, this is awesome. That's what I predict. You're just going to be like, oh, right. So I remember why I love this.
Yeah, I think you're absolutely right. I'm pretty bullish about it. I check in with my new gig from time to time. And, I always come away feeling excited. Buoyed, as I would say. Or buoyed, would you say, as a Yank?
I would probably say buoyed, but I wouldn't say either of those words. I would just say excited.
You say excited. Yeah, that was...
It's just too nautical. I'm not...
That says a man who works for a company called Aquatic.
Yeah.
Buoy.
We have a service actually at Aquatic called Buoy, and I like trip over it every time I say it or spell it.
It's so in British English that is buoy. It's always been buoy. Like, you know, what is the property of being able to float? It is buoyant. Listener, you look at the contortions on Ben's face as he tried to justify pronouncing it that way. Yeah.
Okay, point taken.
All right. But that, you know, very few of these language-based justifications hold water if you start looking too deeply, because English is not very logical.
Well, none of them hold water with buoyant because they float. That's what you're doing. It's never mind. I'll go home.
Maybe we should actually. Somehow we've been talking I've been talking, and you've been very kindly, and listener has been very kindly listening to me vent my spleen.
Oh no! I mean, I love these war stories. I think we should do more of these. It's like, let me tell you about this bug that consumed 2 days of my life.
Yeah,
I mean, great.
I think it's valuable for sometimes to hear them. I mean, it's fun to tell them. But sometimes it's nice to hear them, because then you go back to your desk. You're like, I don't feel so bad about spending 4 hours tracking down this thing now.
Yeah. You know, it's like the old thing about, like, you know, hacking and programming in movies is like people with, like, you know, one hand on each keyboard and like, you know, all the things scrolling by on the screen and the charts and graphs. And in reality, it's just staring at a stack trace for 30 minutes going like, I am bad at my job.
Yeah. Well, in case there was any doubt, you're not bad at your job. I don't think I'm bad at my job, but yeah, feeling that way occasionally.
That's how you feel. You're just like, oh, well, how did this ever work? I don't understand how it even ever worked, let alone what's happening now. So.
Yeah, like, who wrote this? And you know, they get blame, and you're like,
it's me.
Yeah. All right, friend. Well, short of starting a whole new conversation, I think we should finish it up here, unless there's anything you want to parting words of wisdom.
Good. This was a good episode. I like it. I dig it.
Fantastic, mate. I will. Yeah. I will get the minions to edit and put it out soon. And
perfect.
By the minions, I mean me. There are no minions.
Right.
Cool. All right, friend. Until next time. You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbold. Find the show transcript and notes at www.twoscomplement.org. Contact us on Mastodon. We are at twoscomplement@hachyderm.io. Our theme music is by Inverse Phase. Find out more at inversephase.com.